Hey guys, this is a video on my new class that I'm releasing, which is a memory reading and writing class and various other memory things, basically anything related to that I'm trying to put into this class. This one's a little bit different though from my overlay class and my image scanning class, because this one does require additional DLLs, which I've compiled. There's a 64-bit version and a 32-bit version, and the class will automatically handle which one to use. To be clear though, these are not DLLs that are being injected into a process. These are just DLLs that AutoHotkey is loading to use them as an additional library to call on them. The reason that I had to do DLLs versus machine code is because I need the absolute most speed possible. I use memory, I use this memory class basically every single day. This is like my go-to class with my overlay class. Those two together I use all the time. So speed is extremely important, especially when I'm in a game and I need to loop through thousands of entities. I need it to be very fast. So DLLs are kind of the only option for that. But anyway, I'm gonna show you just a really quick example of how you can use it. I have this game in my Steam library that I've loaded up. It seemed pretty simple. I found a health address, a pointer to the health address, and I'm going to use the get pointer function, which takes a base address, applies the offsets to it, gets the final pointer address, and then I'm just going to read from it to verify that it's the right value, and then I'm going to write a big number into it. So in the background here is the game. I have 772 HP. I'm going to go ahead and run this, and it says 772, and then I'll click OK, and now my health is 9,000 something, but you won't be able to tell until I take damage. So there we go, took some damage there. My health got really high. Looks like it got reset when I leveled up though, so I'll just run it again, and it should be back up there again. Maybe you'd want to do like a timer and just every 100 milliseconds write the value. I don't know. Again, this is just an example. I don't actually play this game very much. I'll go ahead and go over the class now though, because that's more interesting. A lot will probably change here. I'll add more comments eventually. But when you create an instance to the class, you have two parameters. The first one is the program identifier. I usually use the executable name. You don't have to though. You can use the Windows title or whatever else you're normally used to using. I prefer the executable name. The access is honestly something you should probably just not mess with unless you know what you're doing. The all is good enough for everything really. There might be certain situations where you don't want all access, in which case you could just specify like RW is read and write, or like TS is like thread and suspend or resume. But for most people, just leave it blank. You'll be fine. Let's see. So read pointer, write pointer are kind of niche functions. Basically, if let's say you have an address in memory that the value of it is a pointer to another address. Well, this will just read that address as a pointer of the process. So if the process is 64-bit, it'll just return you a 64-bit pointer. If it's 32-bit, a 32-bit pointer. Kind of a niche function. I'm not sure how many people will use that. Then we have a big block of read-writes with every possible type. If you want the most speed, you want to be using these dedicated functions. Because they are faster than the helper function below, which lets you specify the type as a string, but not like tremendously faster. I mean, like it's if you're doing 10,000 calls, it might be like 30 milliseconds faster maybe. Anyway, something to note here is there's two write functions. There's one for unsigned and one for signed. These do the exact same thing. Like they are identical. Not these specifically, because those are identical, but say this one for instance. Even though I'm specifying unsigned here and signed here, it doesn't matter. You're writing the same thing. You can just use the unsigned version if you want to. The only reason I've included these is just for consistency and readability. Maybe you want to know that you're writing unsigned, that what you're writing should be unsigned. Well, you can just use that. But it is not required they do the same thing. But I have all the types here. I have floats, doubles, ints, shorts, chars, everything else. Read raw is a buffer of bytes You can read a buffer of bytes if you wanted to, or you can write a buffer of bytes to an address. That's useful for a lot of things. Write byte string is a helper function, which lets you take a string of hex. Here's an example right here. I'll just I'll uncomment really quick. So this you could take this 50 whatever. This is like this would probably be like ASM or something, and you could just type it out, and it would automatically convert that into bytes and write it without you having to do anything. Just a really nice little helper function. And then here's the kind of general purpose read and write functions. If you didn't want to use the dedicated ones above, you could use these two. These let you specify a type as the second parameter as a string. This might be useful to some people who are more used to like the kind of numget, numput kind of syntax where you specify types as a string. That might be useful, so I included that. Again, it's just a tiny bit slower than the dedicated functions, but not enough to warrant you swapping if this is your preferred kind of way. Below that we have getPointer. You've seen that in this example above, which basically converts a pointer path into an address. We have readString, WriteString. These are, string. You can specify a length for reading. If you wanted to read a specific amount of a string. Unicode, if you're reading ANSI or Unicode, one is 1 byte per, one is 2 bytes per. That's important. And then in WriteString specifically, there are two functions, and I might change this later. I'm not sure how I like this, but WriteString will write string that does not have a null terminator, and then WriteString NT will write string that does include a null terminator. Now this is important because a lot of the usage for me anyway, the string that I'm writing to does not include null terminators because there's usually an integer before it that includes the length of the string. So that wasn't super useful for me, so I needed two different functions. I could have just added another parameter, but it seems like such a niche parameter. I'm not sure what I want to do with that. GetModule base address is for modules, dlls, or the executable name. You can get an address to that. Nop is a helper function. It nops X amount of bytes. Pretty basic. That's good for like if you wanted to find the function that does damage to your health. You can just nop the ASM. AOB is array of bytes. This will find you. This will scan the entire process for an array of bytes, and it will return the address to you. Actually, you may have noticed in this code I had some commented out here. This is the AOB scan, which I'll go ahead and run here. Now this AOB is just some random static address that I found just for testing purposes. It's also really far at the end of the program, basically all the way at the end of the program. So it's like worst case scenario for how long it would take to find it. And I'll go ahead and run this really quick to show you the speed. And this is why I wanted the DLLs, so that I could use the multi-threading for speed, because if I didn't have that, this would take ages. So let me go ahead and run this really quick, so I'll show you. So there you go. So less than a second to scan the entire process for the address. Now this is the address, the ABB, I can confirm that's what I found earlier. So with multi-threading, it takes less than a second to search the entire process for this address. Now, this variable here, this 1, you don't need this here by the way, it defaults to 1, but if I write a 0, it will turn multi-threading off. I included that just in case there's like a problem. I don't know why there would be, but if there was, you could turn it off. But now you can simulate what it would be like if you were just using one thread. So I'll go ahead and restart the program. And it would have found it by now, before, but it's still searching. And it's still searching. And there we go. So that took over 8 seconds to find that without multi-threading. That's about 10 times longer. And it gets even worse. I think AMD systems, take even longer. At least my buddy, it took quite a bit longer for him. I'm going to go ahead and put multi-threading back on. And we'll do a search really quick. And there we go, yeah. About 10 times faster with multi-threading. It's absolutely awesome. Anyway, that's AOB scans. So now we have some helper functions for finding memory regions. This is like when the process is running, it has a bunch of memory regions, things that it can allocate to, things that it has allocated to, things that are reserved. And when I'm hooking into a process, I usually want to find a region of memory that I can allocate to, and I can write code there and store stuff there so that I can have the program run those functions from memory. And this will help to find those regions that you can allocate to. The first one just finds any free region. It doesn't care which. So this will just, usually it'll find it from the beginning or something. It's not super useful. More useful though are these two right here. One is find free memory closest. So this will take an input address and it will find the closest region of memory to that address. This is really useful for when you're trying to jump to a custom region of memory to execute a function. So imagine you had an address that had like your health that was going down, and you can then write a jump from that address to your memory region and change a bunch of stuff and then jump back. But to do that, you usually want to do a 5-byte jump, which you can only do if the memory is close enough. Otherwise, you'd have to do an absolute jump, which is 14 bytes, which is quite a bit more. So that's really useful for that. Find free memory nearby is basically the exact same thing, except it doesn't care if it's the closest, just that it's within jump range. At least within the 5-byte jump range. Allocate is just allocating the region that you found with any of these find memory functions. You can specify the access. It defaults to read, write, execute, but if you for some reason didn't want that, you could change it. Top down as well. If you're not specifying an address, it will find a region of memory from the end of the process first, or at least as far back as it can. But if you are specifying an address, then it'll just use that address. Free will free the allocated memory if you don't need it anymore. Write protect is a wrapper function for these two functions below, which is unprotect and protect. A lot of memory static addresses usually are code, and they're usually protected with execute and read only. They don't have any write access. So using these functions, you can add write access to them and then restore that if you need to. So write protect is a simple function that basically just does one write, where it gives write access and then restores the old access. So that's really good for hooking or changing static variables. And then finally there's suspend and resume. These suspend pauses the process basically, and resume unpauses it. This is really good for when like you're trying to well, actually an example later I'll show you. I pause a game before it initializes the Direct3D create function so that I can change the width and the height, because it doesn't support resolutions above 1080p. So that's really, this is a really good use case for that. The rest of the functions below are internal functions for the class. They're not really meant to be called by the user. But that's pretty much it for the class right now. I do plan to add a bunch more to it. Specifically, I have an ASM helper class that I'm using that I want to merge with this, and that's what I use in a lot of my other programs to write, well, to basically to hook functions and write ASM and stuff. But eventually I do want to merge that. I'll go ahead now and show you two two programs that I'm using right now, just kind of like ones that I've just done recently, and I'll go over kind of how they work. Okay, so this first game, my friend actually asked me to make this for him. In this game, there are some items that you can choose, and you can hover over them, but they don't actually tell you anything. You have to pick them up to use them, to figure out what they are, and then just kind of remember from that point on. And he wanted a way to like hover over them and see what they do, so he asked me to write this for him. And I added an extra function here just for this video actually. So I have it injected right now. Well, it's not injected. It's just my overlay drawing some stuff. So if I press left thumbstick on my controller, I can hover over some stuff here. I have only 2 things right now. Oh, I should also mention this is a Unity game. Unity is different than most games because all of its code is stored in a DLL, and then that code is then written to memory when it's needed. I think it stays there after that point, but it won't exist there until it's needed. So you can't find a static address to it, and that's why the AOB scans are so important with the DLL specifically, is because you can find them very fast. Otherwise, it would probably take, 30, 40, 50 seconds, maybe even several minutes if without multi-threaded DLLs. But anyway, so I'm gonna click infinite money here, and this will scan the process for the array of bytes for the money function. It will patch it, and then every time I kill an enemy, I'll actually get like 9,000 money. So it's green now. That means it's activated. It has been patched. And then I'll go ahead and put some stuff down. And then when an enemy dies, I get 9,999, and it just stays there. That's actually not what I was talking about, though. Okay, I went to the settings really quick and muted the audio. So this is actually what my buddy asked me to do for him. So if you open this item up, it'll give you an item here, and if you look at it, you can hover over it, but it doesn't tell you what any of this stuff does. I mean, the icons on some of these might, kind of give you a clue, but there's a lot of items in this game. This is only like maybe a quarter, not even a quarter of them probably, and you just have to remember what they do. So what I did was I added a item hover overlay. So if I click on that, it's patching, and there you go. I found the address and it patched it. It actually looked for 2 different addresses. And now if I open this up, you can see what they do. And some of these are listed as DLC because we don't have the DLC, but you can actually see what these items do now. And he actually helped me with this. He went to the wiki and got all this stuff, and I just added them as an array in game. So when I hover over stuff, I just show that. But that's one use case. And when I said I did 2 AOB scans, one of them was to hook the function that shows these items, so that I can loop through them. And then the other one is to hook the function that is when the window is destroyed. That way I can stop showing it when it's no longer visible. So that's pretty cool. And then I have another one I can show you as well really quick. So this is the one I was talking about earlier, where I'm actually utilizing the suspend and resume, because this one does not support resolutions above 1080p, and I have a 2K monitor, so I want to play in 2K. So when I start the process, I actually start it through my AutoHotkey script, and then the moment that it starts, I pause it, I patch the width and the height, and then I resume it so that it plays at 2K instead of 1080p. So I'll go ahead and run that now. And this is just some debug stuff. But it patches to 2K, and then it'll move the window. And then you get the full experience, which is really nice. And then I'll go to a random battle really quick. This one has some different options. And you'll notice that with this one, the field of view is very narrow. It's the camera's very close to your character. And there's a few other minor things. If I open up my menu here, I have a FOV option here, which I can change. I can increase it. I'll put it to say 100. Now the FOV does kind of make you look like you're further away, so you can change the camera and bring it in a little bit. You could change the angle or the height as well. Another thing is when I'm moving, my camera moves up and down as I'm moving my joystick. And you don't really need to look up and down in this game, so it's kind of annoying. So I have a patch here for the camera, so I can lock the vertical. So if I move my thumbstick up and down, it doesn't do anything. So I can only move left and right, which is how I prefer to play anyway. You can turn max units on. That just shows you as many people as you can. And then that's pretty much it for the menu here. I've made a bunch of other changes in this game as well. But honestly, I can't remember what they were. I've worked on this one for quite a while. But that's pretty much the examples I have now. I have some other ones which are way more in depth, but they're for multiplayer games, so I don't really want to get into it too much. But this class should enable you to pretty much do whatever you want memory-wise. Again, I'm going to be adding more stuff to it in the future, and also I'll probably be working on it quite a bit over the coming months. If you have any recommendations, you can open up some topics on the GitHub page. If you have any problems, you can also write them in the issues, or you can look in the pinned comment on YouTube is my public Discord, and you can add me there. I usually check that once or twice a day. The link for the class will be in the description. It's on GitHub, and hopefully you guys like it. I use this class and my overlay class pretty much every single day. I really enjoy them. Hopefully you guys do too, and I'll catch you later.